Okay, so welcome back to my solving array problems by hand using IB questions. So for this one, so this is a quiz that we took last time, and I've looked through the problem before, but I haven't coded it all the way, so I want to kind of keep it a little bit fresh for myself. I have looked through it, so I kind of know how it works, but haven't actually sat down to do the coding. So let's see how this is going to work. In typical videos, I try and do it where it's like totally fresh to me, so I have no idea, and I can kind of show you how I work through it. But I already have an idea about this one. So for this problem, it's the locker problem, and they're painted the 4 different colors, and we need to figure out a few things here. So A is actually, and like a lot of these times in IB problems, the A is, it's either a check to see, I think it's a check of basic understanding, and like how you might look at this. So locker number 50, so they're figuring out like what locker is going to be 442. So what we should be finding here is that we should find a pattern. And it's like basically every fourth one is going to be a repeat. So we could use modulo is really the best way of doing this. So we could find like, and modulo is like the remainder, right? So 4, 4, 2. If we divide it by 4, it's going to go in there 1, 1, and then 0 becomes 4, 4, 0, remainder of 2. So that's going to be like, so basically that means like we're going to go through 110 cycles of lockers, like if you think of like 4 lockers in each cycle, we're going to go through 110 of those, and then there'll be 2 lockers left over, which means that the color should be the second color, which is white. And remember, that is the answer. So, but that kind of thinking, like how do you solve that one? That's going to, like, you should take that same thinking and then try apply it to your algorithm. So that's what they're trying to guide you through here. Most of the time. Sometimes they're just looking for a quick index, like I think they do later on. But sometimes they're also trying to like guide you towards the problem, towards the answer of the problem. So each student is responsible for painting his locker. They don't know how to determine the color they should use. Construct in pseudocode an algorithm that accepts the locker number as input and then outputs the color that this locker should be painted. So let me share, like this is what and this is what in class I'm gonna, if I haven't done this already in class, we're gonna talk about this as being our like thing we need to look at all the time. So this should be the reference that you won't actually, as it says, you won't be allowed to have this during the exam, but as you're practicing these problems, this should be what you're looking at. Looking through here and finding out like what methods you can use, and what kind of things are allowed or like part of the standard pseudocode library. Because things like, and again, I'm going to mention this in class, but like, I don't know if it's specifically for this problem, but has next is a super easy way to incorporate this into loops. So using like a loop while array dot has next basically means as long as there's something else in the loop, we're going to loop through the whole thing. So we'll use this, I think, a little bit later. It's a great way of searching through an entire array. As long as something's in there, we're going to keep searching through it. And I think, I think we've definitely mentioned this before, but, oh, there's the answers. We don't want to see that. I don't want to see that. So let's go back to this one. So we're going to instruct pseudocode. Okay, so we're going to input the color. So we'll say number is equal to, and let's check. I think I could just write input here because I don't think there's any real specific way they want us to identify the input. But let's take a look at that pseudocode in exams. Let's take a look, input. Again, as you're practicing, this is a good way to look through there. So I don't see anything. And we'll look at the answer key to see kind of how they do it. But I think it's going to be pretty open on taking this. And maybe I'll just say input parentheses so that we know that it's a function. I think that's fine. They don't care about using like scanner or any of that like Java stuff. So, okay, we're going to take the locker number as an input and then output the color that this locker should be painted. So again, we're going to use this one. We're going to use part A to answer this question. And the best way of doing this is using modulo, or just mod in the exam. So in here we could say, like, so when we modulo, I'm trying to think, because sometimes since we start at 1, it's a little bit weird. Normally our numbers start at 0, so it's a little bit just kind of iffy about making sure we get the right number here. But I want to make sure I do this right. So let's say number mod 4. And I might save this as like remainder. Yeah. I'm going to set this as, yeah, I'll set it as just, I kind of didn't plan this well. Didn't plan the writing this well. So I'm going to say this is a number. I'm going to say like color, what color num. It's easier if I make it short, but color num, they do like to have all capital letters in here, so that's important. Color num is equal to number mod 4. And we just basically, so like we're going to take through, we're going whatever locker number we are, we're going to mod it by 4, so we're going to find the remainder of that, and then we just need to check to see what the color, what that is. So if color, so we need to say if color, and they do like capital letters for this, I guess. Color num is equal. So now we need to figure out, okay, so if it's equal to 1, what's it going to be? And I'm trying to think here because I want to make sure that we do get, because normally when we mod and we get a value of 0, that should be the first item in the list, but this is going to be 1. So I want to make sure. So yeah, so I think if we get, if color is equal to 1, then we should get, then we can output, I think that's going to be red. And I can test this. Else if, and they, in the answer key, I remember reading this, in the answer key they use like brand, like kind of ifs within each other, but I think this will be totally fine. I think this is easier, either using else if or using like elif from Python. I think it's just a much easier way of doing that. They like to do like one if inside the other, inside the other, inside the other, then end if, end if, end if. But this just, I think this will be fine. It's a lot easier. And I'm going to say white. And now I'm going to go back and just double check this, and I'll show you how I can double check in just a second. Maybe I should pause this because it's kind of boring, but just along for the ride, and then we'll do else here. Now we'll say output blue. It just saves us a little bit of writing time there. We don't have to write output as 4. And actually, yeah, because that's going to be a bit of a problem. I mean, because let's see. If we did 4, like, if it's locker number 4, we should get blue. 4 mod 4 is going to be 0, because 4 divided by 4 is 0. So, yeah, but, so we could just go through and kind of look at this. Like, what's 1 mod 4? Well, 1 divided by 4 is going to be 0 with 1 left over. Okay, so 1 mod 4 will give us 1. Okay, and we know like locker number 1 should be red. So okay, if we get a remainder of 1, that means it should be red. And if we do like 2, we know locker 2 should be white. So 2 mod 2, or 2 mod 4, excuse me, will give us 2. 2 divided by 4 goes in there 0 times with 2 left over. And so that's kind of just, it's a way for me to double check and make sure my algorithm's doing the right thing. So like if I did, and I could check another one like 6 mod 4, I know the answer should be white. So let's see, 6 divided by 4, 6 goes in there 1 time, 4 with 2 left over. So, and we said 2 is white, 6 is white. Okay, so it looks like our code is working here quite well. So B, that part's done. Automatically, we have 6 points done on this one. Now, let me pause for a second. I'll pull up the answer key, and let's just check our first 2 so far. So first answer should be white, which we said is fine. Input locker, enter a locker number, X input. Okay, yeah, so good. That works fine using the things. I don't think we need to write in the wording in there. Does it say anything about that? No. Yeah, it's one answer for using. So you are going to have to use mod. They're going to remove a point for not using mod in there. I guess that's fair. I think there's other ways you could use this, but mod is definitely the best choice here. So that looks fine, right? 1 is red. Yeah. 2, 3. Yeah, they did X, and they're doing mod in here. I think this, I actually like this way, the way we did it better, because then you don't have to write all that. I think, like, especially if you're thinking about on an IB test where you might be cramped for time, like, thinking about little shortcuts that can get you to the finish line quicker is important. So, like, doing, instead of having to write out this whole thing each time, just writing it once. And maybe even better would be to shorten this. Just say, like, no, maybe not number, because we already have that, but maybe, like, I don't know, color or something short. Not a big deal, but I think saving time is important here. So yeah, that should work. And so yeah, what we're checking was 1 is indeed red, 2 is indeed white, 3 is yellow, and the last one's blue. Okay. Okay, I just had to take a quick, 18-hour break between making these videos. So we'll probably all put into one video, but I'm back. In case you notice that my shirt has changed, my beard is a little bit longer, maybe a little bit grayer. It has been a little bit of time since I finished up Part B. So I wanted to get through Part C, though, and really kind of finish up this problem. So let me move on to this part here. So we did Part B, and now we're on to Part C, which, yeah, is going to kind of follow the same format of having a relatively easier problem to begin with, followed by a more challenging coding problem. So let's look through here for C. I'll change this color. Alright, so C, we want to name the student who's responsible for painting locker number 811. Okay, so 811, Barbara Ivy. But again, I think like this problem should be like keying your mind into thinking about, okay, well, I used the locker number and then I found the name from that. So that should be kind of like cluing you off as to, okay, this is what I probably have to do for maybe the next problem. So, and 2, we're going to actually have to do the pseudocode. Let me get my little notes out on what time we're at on this. Oh, where did I put that? Okay, so let's see. Yeah, so we got to construct and pseudocode an algorithm that counts and outputs the number of lockers that have been painted so far. So this one, I think if you know how to use arrays, it's really not too bad. And all we really need to do here is we just need to keep track of like the count. What is this? Oh, I'm doing like a reflection thing. What is going on here? Maybe I should, somehow I clicked that. I'll just leave that there. So count, we're going to start with the count being equal to 0. And basically all we need to do is we need to run through the lockers and figure out whether they've been painted or not. So this is actually a very relatively easy problem for this. And if you know what they're asking for, all they need to do is loop through and just increase the count every time it comes up true. So all we need to do is loop while, let's see, we'll say painted. I'll do this all they like it all in caps here. Painted dot, and I think we don't need the brackets there really, but I don't think it's going to matter to do this. I mean, there's a couple different ways to do it. We could actually identify the index here and then like do it a little bit more manually. But I think this will work just fine. And we're going to say painted dot get next, and this is good. This is why we need to be really comfortable with that pseudocode sheet, because I'll bring that up here in a second. These have some methods that you can use. So like for an array, you have these things like get next, reset next, has next, is empty. All of these tools that you can use that you don't have to like there's ways that you could actually code this by like very detailed, like, oh, my index is 0 and I'm going to increase index by 1 and do like a for loop like we would in Java, but there's stuff already built into here. And the most important ones for us, take a little tangent here, is probably has next and get next. Because what these mean is, what this means, I guess, the way we can use these is to avoid having to actually find the index. This is just going to get the next item in the array. Get next, get next, get next. Has next is just going to check to see if there is something next. So I think I've talked about this in a few different videos now, but it's because it's so important. We can use this to really go through arrays really quickly. And all we need to do is say, like, okay, as long as something is next, let's get the next one. And in here also, I always kind of do this. I feel like I don't leave myself enough room. And I want to say if painted.getNext is equal to true. So basically, as I go through the painted array, I keep checking the next spot in the array. And if the value in that next spot in the array, and we're talking about this array here, right? If it's true, then count. We could say plus plus, or we could say count is equal to count plus 1. Either way, we should be fine here. They might like us to do an end if. I don't think it really matters. End loop. But that's all we need to do. Just check through the array and count how many of them are true. And then I think at the very last thing they want us to do, make sure that we need to output it as well, so we can output. We'll just say count. We could write like a little phrase in there. The number of lockers that are painted is, but they're not really going to care about that. They just want to see the output, so that should be fine. And let's pause for a second. Okay, we'll put the answer sheet here. Let's pop this over. Let's make sure we get all this, and let's see if we got everything in here. Okay. And then, yeah, so if painted is true, then count plus 1. And so it's really, this is actually and they did, looks like they did slightly differently. They did the index version where they identified k is equal to 0 to begin with, and then ran through 2,399. That's fine too. I like this way. I think either way is fine. I might actually be more comfortable with this way because then it's dealing with the actual index, and I know for sure that I'm printing the right thing. But I think both of these should work. I think this is a little bit more like the IB pseudocode kind of hidden way of doing it, whereas I think this is a little bit more, their answer is actually a little bit more, I don't know if direct is the right word, but it really clearly uses some indexes, which is kind of useful. Alright, sorry, one last one. Okay, and we're going to look at part D now. Okay, now part D is actually really important because, okay, in B and C2, they both said construct. And this one, the key word here is describe, which has a very different meaning. Construct means you actually need to write the code. Describe just means you need to, well, it doesn't just be like, well, I'm going to kind of, I mean, they still want some details. It can't just be some kind of random ideas here. But they do want some specific details, but you don't actually have to code it. And what they want to do is so we don't need to construct it, but we do need to clearly identify it and describe why it's going to work. And also in here, they're going to like the fact that it's an efficient algorithm. So we'll go through a couple steps kind of leading to the highest level answer to this. The first thing is to understand what they are actually asking for. I'm trying to delete this. As much as I like the upside down writing. They want to describe an efficient algorithm which accepts a student's name as input and then stores the corresponding locker number and whether or not it has been painted. So the easiest way of doing this is we can just say student is equal to input. So that's at least, okay, so this is enough to say that we're getting input from the user and we're saving it as student. And maybe even better would be to put this in all capitals. IB likes having the variables all in capitals for some reason. That's just to distinguish. But okay, so we're accepting a student's name as an input, and then we need to output the corresponding locker number and whether or not it's been painted. So for example, like we should be able to give them an input of Abat Robert, and then it should print out 561 and then true. Or if we give them Ziaz Zaire, that should print out locker number 45 printed true. So we need to take in an input from we're taking in the name from the user, and in this case, like we're expecting that it's gonna match this, right? They need to, if they give us Robert Abat, like not, if they didn't put the names in the right order, this wouldn't work. They're going to put the names in the right order, and they're gonna give it to us. And then we just need to figure out, okay, how can I figure out what locker they're at and whether it's been painted or not. So I mean, we should think through that. Like, okay, if someone gave me Baber Ivy Baber, I don't know. If I got that name, what would I do next? Well, I need to find her in the table, right? Oh, she's right here. I find her in the table here, and then I need to see, like, okay, her locker is 811 and her painted is false. So we start with her name, and then we kind of find the corresponding spots in the other array. And that's what we're going to do here too. We need to, oh actually, and I'm already starting to code this like a constructing code instead of that. So so I should be really describing this instead. So take input from user and save in a variable. And now really what we want to do is search through this array to figure out like where the name is at, like what is the array, what is the index position for the student that we got. And this is where it gets a little bit tricky. There's two ways to search, two ways that we have at least to search through this array. One is a linear search, which means we start at 0, 1, 2, 3, 4, 5, 6, 7, and we go all the way down. Or the other option is a binary search. A binary search will look at the very middle value. We'll take the input, look at the whole array, and then it's going to look at the middle part of the array. And it's going to say, okay, is our name, like whatever name or input, is it in the middle part, or should it be a little bit higher up in the array or further down in the array? Like if we got a name like, let's just, well, okay, my name is pretty close to being in the middle, so let's say Moden Casey was in the middle. So you have this big giant array, my name's in the middle. And then we're going to look up, I don't know, and then say like, oh, did I pause it? Okay, no, forget it. So then say I'm going to look up like Abidaan. Sorry, so if I look up like Ariel, Abidaan. So, like if that's the student that gets entered, the first thing that would happen is they would compare him against my name. And they would say, okay, well, Mr. Moden, Casey Moden is right in the middle. Okay, Abidaan is, he must be in the upper part of that because his name is alphabetically lower than Mr. Moden. So then they would look in the middle here. And they would find, I don't know what kind of name they would find right here, like, I'm trying to think of like last names. Haverford. Al. I don't know, I maybe made that name up, maybe not. And they say, okay, and they compare, so they started with my name, and they said, okay, well, he's definitely not there, he's not in the bottom half, he's going to be in the top half. Okay, let's take that top half, divide it, and let's see, okay, in the middle here, we have Haverford's right in the middle. Abidaan's name is still, like we already crossed this part out. Now we're going to cross this part out because we know his name isn't in this range. It's got to be somewhere up here, okay. And then we're going to divide this one further in half, and what kind of name we're going to get here? Edison S or something. And then we compare Abidaan's name against Edison and say, okay, let's see. Abidaan's is, well, it's still going to be less than S. Okay, it's still less than Edison, so it can't be in here. So each time what we're doing is we're splitting our data in half. Because our data is sorted alphabetically, we can split it in half. Look at the very middle, see if the names match. If not, we'll look either in the top part or we'll look in the bottom part. That's what a binary search does. So that's what we should be doing here. We're going to take input from the user, save it in a variable, and then search. We want to search student name using a binary search to find index of student of, say, input. I keep messing this up. Alright, sorry, I keep kind of like having to send an email or something, come back into this. So we find an index of the input. So if we get an input of Abidaan, we're going to use a binary search to find the input, find the index of the input name, maybe. And then we can use index to find corresponding data and locker number and painted. Output the result. Now this is so far, I'm going to get 3 out of 4 on this one. So we're going to take input from the user, we're going to save it in a variable, search student name using a binary search to find the index of the input. What did I say? Maybe I meant to say given here. I don't know if you can even read it anyways, but given, I don't know. Input given. So I think I'm trying to do too many things at once. And then use the index to find the corresponding data in locker number and pin number output. And then output the result. That looks fine. We're going to describe the problem here. Like this looks good. We're hitting all the points. Except one thing right here. They say an efficient algorithm. So what they're going to ask you to do, that's very strange. I didn't know that was going to happen. What they're going to ask you to do is to describe why it's efficient. Like binary is efficient because it halves the data. Like that, it splits it in half. This is useful. And the only reason we can use this, oops. Because student names is sorted. Because it's in alphabetical order, that means that we can actually apply this binary search. If the data is not sorted, if it's just randomly in there, then we cannot use a binary search. But thankfully, it is sorted, so we can use it, and it's a much more efficient way. I mean, compare that to, there's someone knocking at the door. Compare that to if we did a sequential search where we're looking through every single last thing in the data. You know, we might end up, it might take for a long time, especially if our name is down towards the bottom. It's going to take a long time to get there. A binary search will, like, cut the data in half each time. Get rid of the half we don't care about, and then continue to cut it in half, cut it in half, cut it in half until it finds the answer.